Okay, the last one for today is question 5, which is a function question, which, just like fractions, functions should be your friend. So let's give this one a go. So for part 1, they want you to do the derivative, so f dash x. Just be really, really careful that you don't mix up your f dash x's with your f negative 1, which is the inverse. The examiner's notes for this said that there were people that did get them confused, so don't be one of those guys. So let's do this. So my f of x, let's start off with that. And because I'm going to differentiate it, I'm going to rewrite that with a negative power, so negative 1 there. So then when I differentiate it, I'm going to get negative 15, 2x plus 3 to the power of negative 2, and because it's a composite function, I've got to make sure they also multiply by 2, and that comes from differentiating 2x plus 3. So if I tie that all up, I'm going to get negative 30, 2x plus 3, all to the power of negative 2. They're then asked to say, use your result to explain why f has an inverse. So you've got to remind yourself what you're after. So you're after this function, and however it looks, and what you want to know is that it's a 1-1 function, something like that. So it goes from 0 to 6, and it doesn't fold back on itself, or it doesn't sort of go back over there, because what you don't want is multiple x values for the same y value. So you don't want that scenario there. So we just want a nice smooth part of a curve. So how does looking at the derivative help us with that? Well, we can look at the derivative and decide if there's any, it tells us more about the nature of the function. So let's just rewrite it like this. So we can look at that more clearly. So that's our derivative there. And we know that our domain is that our x values are always going to be between 0 and 6. Not that it matters in this case here, because whatever our x values are, when we put them into our denominator of our fraction, they're going to be squared, which means they're always going to be positive. So we're going to have negative 30 divided by some positive answer. And even if x was 0 there, it still is going to come out to be a positive number. That means that our derivative is always less than 0. It can't equal 0 because there's no x value that we're going to be putting into here that makes... there's no x value here that would make this bracket 0. And we couldn't make it equal 0 anyway because we couldn't divide through by 0 because it would make the function undefined. So our gradients are always going to be negative. So my little picture here I drew actually looks wrong. I was just drawing it to make a point. It would actually look more like that. Between, let's say, x is 0 and x is 6. Also, because our function can't equal 0, it means we can't have any turning points, which helps us with this kind of idea here. So we know that even if it's coming down, it's not going to come back up again and end up with two x values of the same y value. So that also confirms for us that that our function has an inverse because there aren't any turning points. Okay, let's do part 2, which is our inverse function. So what we can do is we can start off with what they gave us. And then what I can do is I can swap the x's and the y's around and then rearrange them all to make y the subject. So this is a skill that hopefully by now you have got pretty much sorted, because it pretty much always comes up having to find inverse functions. So I've just been doing that while I've been talking. Last step now is to divide everything through by 2. So that'll be 15 over 2x minus 3 over 2. If you wanted to make that as one fraction, you could. It would be 15 minus 3x all over 2x. But either ones are fine. For the domain and the range, they've already given us the domain of the original function. So for the inverse function, that gets swapped around. So for us, we know that the inverse function, so f of -1, has to be between 0 and 6. We need the domain of our inverse function, which would be the range of our original function. So if we go back to our original function, we know that the x values have to be between 0 and 6. So if we substitute 0 into the original function, when x is 0 in the original function, y was 5, and when x was 6 in the original function, y was 1. So our range for our original function is between 1 and 5, so that becomes our domain for our inverse function. Oops, sorry, that should be a 1. So our x values for our inverse function are between 1 and 5.